Hey guys, Fred here at Math and Engineering. We're back, we're sketching some graphs, we're sketching some functions, we're doing transformations of those functions, and we already did one question, the sine question, a video before this, so go back and take a look at that if you haven't yet. Also before that video, we did just a video outlining the rules of what we're going to be doing here. So like I said, if you're just tuning into this video and you haven't looked at that one yet, obviously go back and familiarize yourself with what we're doing, because we're going to go a little quicker here, and we're just going to breeze through this one. So let's read the question. Starting with the graph g of x is equal to root x, apply transformations to sketch f of x equals 2 times root x plus 1 minus 1. Okay, so a couple things to note here is that the negative 1 is outside the root and this plus 1 is inside. The 2 is applied to the entire thing. Okay, and we're starting with root x. Okay, so this question is going to want us to show each step along the way for full marks. So the first step is going to be g of x equals root x. So that's the first one that we're going to draw, and I'm sure most of us know what root x looks like. If you don't, if you forget on the exam, what you can always do is just in your head plug in the first few numbers of g of x is equal to x, root x, and plot it. Okay, so let's try it that way. Okay, so when x is 0, g of x is 0, right? So we'll start there. Okay, when x is 1, okay, g of x is 1. Okay, so we know that. All right, and when x is, let's say, 4, all right, when x is 4, okay, g of x is 2, right? So square root of 4 is 2. So knowing that, okay, and if we go like this is going to be 4, this is 2. Okay, we can go ahead and draw our root x graph. Okay, it's going to look like that. All right, and this is going to be 1 and 1. All right, and okay, so that's pretty much it. That's the first step. We've drawn root x, and now we need to go ahead and start applying some of these transformations that we have here. Okay, so let's do the plus 1 inside the root. All right, so this one's going to be g of x is equal to, that's going to be g sub 1 of x, just so we know that that's the first step, and that's going to be x plus 1. Okay, so x plus 1, and what is that going to do? Well, x plus 1 inside the root is going to shift the graph left. Okay, it's going to shift the graph 1 unit to the left. And you can go ahead and, like I said, plug in numbers, okay, if you're not sure, in a function like this, and you should be able to plot it out. All right, and that's kind of an emergency measure, though, just in case if you do forget what plus 1 does. Okay, but x plus 1 inside the root is going to shift the function over 1 on the x-axis. Okay, so instead of starting from the origin now, we're going to start from -1 on the x-axis. Okay, and instead of going from 0 to 4, it's going to go from -1 to 3. Okay, and let's just go ahead and plot that. So it's going to intersect y at 1 now, right? Because if we plug in x equals 0, all right, so when x is 0, y is 1. Okay, g of x is 1, and it is going to go up to 2 on the y-axis, right? So let's go ahead and plot that. Okay, so we have 2 on the y, 3 on the x, and then we have our y-intercept of 1 here, and our x-intercept of -1. All right, perfect. So that is our second step. All right, we've drawn root x plus 1. So let's go ahead and apply another transformation here, and this one is going to be the -1. Okay, so we're going to have root x plus 1 minus 1. All right, so that -1, all right, now that it's on the outside of the function, okay, is going to shift the graph down. Okay, it's going to shift the graph down on the y-axis a little bit. All right, so the x plus 1 on the inside of the root shifted the graph left on the x-axis. Now outside the argument of the square root, the -1 is going to shift it downwards. And that's just exactly the same thing that we did here. Okay, so we're at -1, okay, right now, x-intercept, sorry, and we're going to come down over here to -1, okay, on the on the y-axis. And now our x x-intercept and y-intercept are going to both be 0. Okay, it's going to intercept in the origin. And now as you can see here, the range is from 2 to 0, okay, from this little piece that we're plotting of the root. And that's a little bit of a trick, guys, so we're going to work with the same piece of the function, okay? We're taking kind of the same domain and the same range here, and we're just moving this piece around, okay? Because if you have some really long function, it's kind of hard to shift it, okay? But if you have just a finite piece of the function here, you can shift it around as you require, okay? And that's what you can see as we're doing here. Okay, so this little piece of our function now is going to start at -1 here on the x and the y axis. It's going to intercept the origin here, okay? So, and our range, remember, was 2. So it's going to go from now, instead from 2 to 0, it's going to go from -1 to 1, okay? So it's going to go all the way up to 1 here, and our domain is going to be the same still, -1 to 3, right? So this is going to be 3, and yeah, it's just going to come up like this, okay? All right, so that's the third part of the function, okay? We are now intersecting at the origin. Okay, our domain is still 4 units from -1 to 3. Our range is still 2 units from 1 to -1, but we've just shifted it left with this step and down with this step, okay? And now, finally, the last function and our final answer, okay? And I'm gonna go ahead and let's just write it here. So we have f of x is equal to 2 times x plus 1 minus 1. So as you can see, we've added a constant 2 outside the entire function here. And if you go back to the original video where we did the rules, you'll see what that does. And what that does is it's going to stretch the function vertically by a factor of 2. Okay, so if we look at our total range here, okay, right now we have it from 1 to -1, and we've had it a range of 2 units for the whole question, okay? So when we stretch that by a factor of 2 now, okay, now our range is going to be from 2 to -2, okay? So it's going to go from the range of 2 to a range of 4. It's going to increase by a factor of 2. So let's go ahead and let's draw that. So nothing else is going to change except the fact that we're stretching it vertically, right? So what that means is let's just start by drawing that. Okay, so let's start by drawing our range now. Okay, so now that we know that it's going to be from 2 to -2, and well, what's going to happen now? We are going to have the same domain, right? We're going to have -1 and 3, perfect. And let's go ahead, it's going to intersect the origin, same as before, all right? And we're just going to draw 3 points like that, okay? So that's maybe a good trick that you can utilize, all right, is if you know that this 2 is going to transform the range, draw the range, okay? The domain is going to stay the same. Make the points that you need to connect the line, all right? So we know that it's going to go through the origin. We know that it's going to, at -1, on the x-axis, it's going to be -2. And we know when the x is 3, it's going to be 2. And then we can just go ahead and connect those lines. And we can indicate for the marker exactly where these are intersecting, so we get full marks. All right, and that's pretty much it. That's function f of x equals 2 times root x plus 1 minus 1. Hopefully that helped. You know, these aren't hard questions at all, but they do require a little bit of practice. And you know, if you just keep doing, if you do these 2 videos and you do a few more problems in your book and you kind of memorize the rules for doing these problems, you really shouldn't have a problem on the midterm. So thanks for watching these videos, guys. Like and subscribe if you're enjoying these. Stay tuned for some more content. Thanks.